Okay, so in this video, we're going to take the experimental design a step further and talk about sampling techniques. So how do I go and sample this population? What do I do? So a census is a count or measure of the entire population. It's everybody. The whole shebang. The whole bamboozle. Now, this is extremely expensive. You're like, well, how do you know it's expensive? Think of it this way. For those of y'all that know this, if you know it, tell your neighbor. If you don't know it, listen to your neighbor. How many times or how often does the United States do a census, a population census? Every 10 years. Why every 10 years? Why not every year? I want to know the population of the United States right now. I don't want to wait 10 years. Well, they got to go get all the data from everyone in the U.S., and that takes a lot of time, and a lot of time, a lot of talent, a lot of energy. It takes a lot to survey the whole U.S. population. So they do it every 10 years. And if you don't know that, then now you do. Also know that by law, you're required to respond to the census. So if, like, you get stuff in the mail, and you're like, I'm throwing that away. I don't want to respond. They don't need to know about me. And you throw it away. And they send you something else. You throw it away. They send you something else. You throw it away. They call you. You hang up on them. They send the person out there. They send the person to your house. Slam the door in their face. They send the person to your house again. Slam the door in their face and tell them to stay off your property or you're going to take matters into your own hands. Well, guess what's going to happen the next time they send someone else out there? They'll send someone else out there with a police officer. By law, you have to respond to the census. But anyways, for most purposes, we're not doing the whole census because it's so expensive. So what do? Well, we do some sampling. A sample is a count or measure of part of the population. But when you do this, count or measure of part of population. Okay, anyways. When you do this, you have to make sure that your sample represents the entire population. So you can't be hasty here. You can't just say, okay, you know what? I want to know what Lufkin thinks of building a new football stadium. And so I'm going to go only to those at the football game that's going to be in town. And I'm going to ask them. And then those are going to be my results. Well, the issue with that is it's not representative of the whole population. It's the whole town of Lufkin at the football game. Those of y'all that just said yes, don't get mad. Don't be mad because you're stuck in traffic, okay? No, the whole town is not there. The football stadium will not hold the whole town. You're just mad because you get stuck in traffic, okay? Anyways, on a serious note, we got to represent the whole population. We have to sample everybody. So we're going to talk about some ways to do that. One way is a random sample. A random sample is one in which every member of a population has an equal chance of being selected. In other words, you and I have the same chance of being picked. But we could take that a step further with a simple random sample. A simple random sample is a sample in which every possible sample of the same size has the same chance of being selected. So you would give each, if we're surveying people, you'd give each person a number and use a random number generator to select 100 people. So what that's saying is, or an example of that would be every group of 100, every 100 people, or I should say 100 person group, has the same chance. Yes, you and I have the same chance of being in the group, but if I were to look at one 100 person group and another 100 person group, maybe they overlap, maybe they don't, those groups have the same chance of being selected. That's a simple random sample. Now, that's not always practical, and it's typically not what's used, because the issue with a simple random sample is that it may not look like the whole population. So we tend to use, or I'm not going to say we tend to use, we could use what's called a stratified sample. A stratified sample guarantees that members of each group within a population will be sampled. So I'm just going to keep it simple. I normally teach this dual credit, which means we have freshmen all the way through seniors. So just kind of bear with me on this example. But let's say you have 12 people here. Let me just draw them. Here's a group of 12, or don't laugh at how my stick figures become more and more disfigured the longer I draw them. Okay? Be happy they're getting drawn. Let's see, that one's neck got cut off. There we go. He's got a neck now. Okay. Okay, so I can break these up and say, okay, these are my freshmen, these are my sophomores, these are my juniors, and these are my seniors. Stratified sampling is when I can separate them into groups, and then I can say, you know what, I'm going to pick one person from each group. I want to survey 4, so I'm going to pick him. Maybe I'd pick like that. Where if I'm going to look at what they think of the food served in the cafeteria, seniors may be like, you know what, I don't like it. I just have a year left. I don't care. It's okay. Freshmen are, it's terrible. It needs to change. I gotta eat this for 3 more years. Blah, 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 blah. So you don't want to pick just 4 freshmen, just 4 seniors. You want to get a mix of everybody. You want freshmen to have a voice, sophomores, juniors. You want everyone to have a voice. That's stratified sampling. Now, another method of sampling is called cluster sampling. So when a population falls into naturally occurring subgroups, each having similar characteristics, a cluster sample may be appropriate maybe the appropriate technique. So an example of this would be like you randomly pick two classrooms and survey all in that room. So the way I like to think of cluster sampling, you're gonna laugh at me and say I'm a nerd when I can't take that much credit. Because I like to think of it with Frodo saying, I think it's Frodo. No, it's not Frodo. See, I told you I'm not a nerd. Who is it? Gandalf. Why did I say Frodo? You shall not pass. So let me copy image. I like to think of cluster sampling as this picture. You shall not pass. Like, what do you mean I shall not pass? Well, answer my question and then you can pass. That's how I think of cluster sampling. He is standing at the door to that room. He will not let you walk out the door unless you answer his question. That's what I like to think of on cluster sampling. Now, obviously I'm not the nerd because I said Frodo. Why I said Frodo, I don't know. But anyways, that's cluster sampling. It is like Gandalf standing at the door. You shall not pass. Yes, you answer my survey. But you're going to sample everyone in those two rooms. Now, another method that we could use is called systematic. Systematic sample is where you order the population in some way and then select members of the population at regular intervals. So maybe you alphabetize. So you alphabetize the students and then you select the 13th student. So select 13th. Hang on. I left the word out. You select every 13th student. And alphabetize the list. So, you picked Billy Bob. Okay, then you count 13 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, I gotta survey you. And then you count 13 more people. Oh, I gotta ask you. 13 more people. Oh, hang on, gotta ask you. That's systematic. And then the worst type of all, I'll be honest. I mean, yes, you can get a survey, but it is terrible. It's convenience sampling. Do not do this. Do not do this. Convenience sampling is where only members that are easy to get are sampled. This type of sample often leads to biased studies. Asking the first 100 people to a football game, should we build a new stadium? Yeah. Why would they say that? Well, they're passionate. They're the first 100 there. They're easy to get. They're going to the games. You're going to have a biased answer. Don't do that. Don't do that. Don't do convenience sampling. So an example. Sample first 100 at a game. It's going to be biased. Don't do it. Okay. So let's look at an example of all of these where we had to decide what kind of sample and then if it's biased. So you're doing a study to determine the opinions of students at your school regarding stem cell research. Identify the technique you're using and then discuss any source of bias. So technique A, you divide the population with respect to major, and then you randomly select and question some students in each major. Hang on, before we do this, I left something off that might help us here. Stratified and clustered sound very similar. So the way I remember them, stratified, we got some students from all groups. So just stratified, remember some from all. Cluster, we surveyed everyone in 2 rooms. Now, maybe we had 200 rooms. We just picked 2 and surveyed everyone. We were Gondolf. You shall not pass. So this one is all from some. So if you remember that, that'll help you keep those 2 straight. Okay, back to the example. So we divide them up by major, and then we select some students in each major. So this sounds a lot like what? Some from all. So which one is some from all? Stratified. So this is stratified. So then what could be a source of bias? Well, certain majors may lean a certain way. So maybe your biology, pre-med, whatever, those majors may say, oh yeah, stem cell research, good, let's do it. Others are like, no, I don't know anything about it, it's bad, don't do it. So that could be a bias. That's why we're getting some from all majors to help overcome that bias. Okay, B, you select students who are in your statistics class. So you're only picking students that are sitting in the room with you right now. Well, that is a convenient sample. Let me make sure I'm writing it in the correct color. Red. Okay. There we go. This is a convenient sample. You're picking the ones that are the easiest to get. Easiest to get. Well, what are some issues here? What are some biases we could have? Well, you're more educated. So, maybe more educated on the research. And then also, we may not be representative of the population. Okay, so those are a couple of biases with convenience sampling. Next one. You assign each student a number and generate random numbers. You then question each student whose number is randomly selected. So we give each student a number, generate random numbers, and then pick each person that's selected. That is a simple random sample. You're like, wait, how? Go back and look at the definition. I'm over my 20 minutes, so I'm trying to finish this example. But look at the definition. That is a classic simple random sample example. This is really the best one. So the bias here would be that the wording of your question could sway the results. Like, what do you mean? Hang on. I'll explain here in a second. So what I mean by this is, if I went up to you and said, do you support stem cell research? What word did I just plant in your mind? Support. Or if you think about restaurant surveys, did you have a good experience with us today? What word did they just put in your mind? Good. Think about negatively spun questions. Would you support the development of a weapon that could kill millions of people in an instant? You're like, wait a minute, kill millions of people? No! Kill millions of people in... No, that's bad. So the wording of your question can sway the answer. Assuming this doesn't happen, this is probably your best bet. Okay, next one. You select a class at random and question each student in the class. So we're getting each student in the class, so all from one class. What is all from some? This is a cluster sample. So let's look at our biases again on this method. Well, certain classes may know more info or may have more knowledge. Or they may know less. Would your English class know as much as your biology class? Probably not. Which means it may not be representative of the population. So it kind of goes back to that one. Okay. And then the last one. You assign each student a number, and after choosing a starting number, you question every 7th student. That hint right there tells us that this is systematic. Okay, so let's talk about a bias. The main bias on systematic is if a pattern is noticeable, bias could be introduced. Now, with that said, you often wouldn't notice it until after you picked your people. So you're like, what the heck, dude? But what I mean by pattern, it may not be intentional. It may be that every 7th person, just by chance, happens to be a female. What the heck? When did all this work? And my sample's biased. So then that's where, remember in the last video where we talked about sources of error? That's where you would say, okay, look, I've just spent thousands of dollars on this research. I'm publishing the paper. But then as a source of error or bias, you could talk about that. And analyzing the data, I noticed where most of my respondents in the systematic sample were female. This could lead to blah, 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 blah. So, anyways, there's our example. We talked about how to collect data. I wish we had more time to go into it deeper, but in this class, we don't. So that's all of chapter 1. Remember that you are loved, you are created to do wonderful things, and you are awesome. Always believe.